A thunderstorm complex can die out, yet leave behind a spinning engine in the middle of the atmosphere. That leftover swirl is called a Mesoscale Convective Vortex, or MCV, and it can help restart storms, focus heavy rain, and sometimes even seed a tropical cyclone. Mesoscale simply means weather on the scale between small cloud processes and huge continental systems. An MCV is usually about 100 to 300 kilometers across, with its strongest rotation not at the ground, but several kilometers up, often around 3 to 5 kilometers above us. It commonly forms inside a larger cluster of thunderstorms called a mesoscale convective system. As the cluster matures, the violent leading storms may race ahead, while a broad shield of steadier rain develops behind them. This rear rain area is crucial. Inside it, water vapor condenses into raindrops and releases latent heat. Meteorologists call that diabatic heating, which just means heat being added to the air by physical processes such as condensation. That warming creates a mid-level warm core. Warmer air is less dense, so pressure falls in that layer. Air from around the storm is drawn inward to fill the lower pressure pocket. As that air converges, Earth's rotation bends the motion and helps it spin. In the southern hemisphere, that circulation is clockwise. If the storm complex is wide enough for rotation to dominate, instead of leaking energy away as waves, the swirl can become balanced and long-lived. But size is not enough. The wind profile must also cooperate. If winds change too sharply with height, strong vertical wind shear can tilt and tear the developing vortex apart. In weak shear, the warm core and circulation stay stacked, allowing the pressure gradient and spin to reinforce each other. Once the parent thunderstorms fade, the MCV may remain as a slow, cloud-filled pinwheel of moisture. Satellite water vapor loops can reveal the swirl after the taller storm clouds clear. Doppler radar can also help, not just by showing rain, but by showing broad inbound and outbound wind patterns in the middle atmosphere. Forecasting these systems matters because they are efficient rainmakers. An MCV can lift moist air repeatedly over the same area, helping new storms fire during afternoon heating or over hills and ranges. That is why they are linked with flash flooding, especially near complex terrain and coastal zones. In northern Australia, the story can become even bigger. If an MCV or decaying monsoon thunderstorm cluster drifts over the warm Coral Sea, Gulf of Carpentaria, or waters off Western Australia, the ocean can feed it fresh latent heat. With low wind shear, storms rebuild around the old mid-level spin. The circulation can work down toward the surface, and a tropical low may begin. Most MCVs never become cyclones, and many are subtle features hidden inside broader weather patterns, but they are a powerful reminder that the atmosphere has memory. Yesterday's thunderstorm cluster can leave behind tomorrow's rain focus, flood threat, or tropical seed. For severe weather awareness, watching the leftovers can be just as important as watching the storm itself.